Oh, here.
I'm not lying though,
Let's start by, the other day when we were practicing for our quiz, I gave you this little worksheet packet. And let's go to the back of it. And it says, the packet says 3.13, but if you go to the back of it, it's got 3.14 in there. So it looks like this on the front, but we're going to back where it says worksheet A. So on the back of the third page, on the back of the third page, we're on worksheet A. Okay? So here we go. Let's see what we remember. We spent so much time graphing these things on our calculator. Let's see what we remember. So look at problem 1 on worksheet 3.14. Can you rule out any of the multiple choice answers right off the bat? I hope you can. Can we rule out C and D? Why? They're cosines, and cosines have symmetry about the x-axis or the polar axis, the horizontal axis. So this is clearly a sine. All right, can you figure out which of the sines it is? Do you have a gut feeling first? We can check a point. If you have a gut feeling, A. A is your gut feeling because it's stretched up, and that's the positive one. But how could we check? We could plug in the point pi over 2, for example. And if we plug in pi over 2, we get 2 plus 4 times 1, which is 6. So that you're right, A is the 1. Can you do something similar with B? First of all, can you rule anything out in B? Yep, you can rule out A and B because this is a, oh, you already did it. This is a cosine problem, so it's going to be oriented sideways. Which one do you think it is? Just gut feeling. Think it's C or D? D? How could you check if you wanted to?
Yes.
You could plug in pi, for example, and see if it worked.
Well, it says -3 cosine. It's facing left.
Yeah, yeah. Yep. Okay, how about number 3? Can we rule out any in number 3? We can definitely rule out B and D. Why can we rule out B and D? Doesn't have enough petals, it would have to have 8. But if it were equation B, wouldn't it have to have 8 petals? Okay, it doesn't. All right, so B and D are out. What do you think about A and C? Could we plug in a point? Absolutely. But do you remember anything? What? A. It's A. How do we know it's A? Because every cosine rose we graphed yesterday, where did its first petal start? It's oriented, its first petal is there on the x-axis or on the polar axis. But again, let's say you forget that by May 13th. Could you plug in 0? Yep, and when you plug in 0, you're supposed to get 6. 2 times 0 is 0, the cosine of 0 is 1, A works, just by plugging in the point. All right, what about number 4? Now I don't have the whole graph, now I only have part of it. Do you have a feeling? I graphed it on a rectangular system, so it's amplitude 3, periods pi, 2 pi divided by 2. So there's a picture of it. Now, it's a little bothersome to me because when I look at the polar piece that I've been given, this angle right here is what? What would that angle be in the picture? 7 pi over 4. And unfortunately, I don't even have that in my period up here. But wait a second. That point right there, is 7 pi over 4. 7 pi over 4. 3. Right? That point needs to be moved up into this period. So wouldn't that be the same as the point 3 pi over 4, negative 3? Look, kids, see this point right here? 3 pi over 4 is negative 3. But I can't plot a negative r, so I translate it into that point and it ends up getting plotted there. So once again, this point on the graph is 3 pi over 4, negative 3. R is negative 3. But I can't plot that, so I translate it into positive 3, 7 pi over 4, which is exactly the point that's on my graph. Right? So what's my interval? Hello? Good to see you. Good to see you. Okay, so what's the interval that's on my graph? Well, this piece right here, this rose right here, came from this right here. Because we started at the pole, we came out this far, and then we came back to make that petal. That's how that petal was made. So what interval is that? If we're looking at the interval from pi over 2 to pi, right? Pi over 2 to pi. Now, if that interval gave me this petal, won't this interval give me another petal? But wait, I'm not supposed to have just 2 petals, I'm supposed to have 4. Where are the other 4, or other 2 gonna come from? Another wave of it, exactly. Remember, we're going from 0 to 2 pi, so that means we're going through this wave twice. So we're gonna have another petal down the road.
Well, aren't we only going from like 0 to like the end of the period? Sure.
That would be fine for here, but look at your problem, 0 to 2 pi, I have to go another period. And what will happen is, I'm gonna get I'm gonna have another negative value here, and that negative value is gonna happen at 7 pi over 4, and that's gonna flip me that over to 3 pi over 4. See, there's no point plotted, it's actually literally at 3 pi over 4 here, because that came out negative. But if I do another period, at 7 pi over 4, it's going to be negative again, and that's gonna flip me back to 3 pi over 4. Remember, in rectangular coordinates, there's only one way to name every point. So one period is enough. But in polar coordinates, there's more than one way to name every point. So to get it all, you might have to go around more than, you have to go around at least once. At least once.
Okay.
Okay, to get it all. Because each little piece is only gonna make one here, they're only gonna make one petal. Yeah, that's gonna make one petal. These are my petal. That is my petal. That's the one I've got. This one would probably be the petal you're quadrant 1. Okay, so the answer is B. All right, now let's look at number 5. Number 5, I have the whole graph. right, so there it is rectangularly, I don't know. Let's see. If the domain is restricted to pi over 2 to 3 pi over 4, so I'm only looking at that part. After this conversation, would you agree that that's gonna be half a petal? It's gonna be half a petal, right? Would everybody agree with that?
Yeah.
All right, so I gotta figure out which half, or what point is. So, let me go ahead and let me look at this with, actual points. So pi over 2 is 0. And 3 pi over 4 would be -6. Right? Well, I can't even plot that, so I'm gonna rewrite that. Where is that point gonna end up being plotted? At 6, 7 pi over 4? So look at your picture. You have a point at the origin. You're going from here to here, according to the problem. You have a point at the origin, and you're moving to 6. So the origin is point E. And what point am I moving to? If I'm moving to this location, I'm moving to point C. So it's E to C. This is going from E to C. From E to C. And if I kept going, it would come back to but I only want half the loop in this problem because I'm only going from here to here. So it's this piece right here. I'm going from this point to that point, E to C. All right, number 6, they did not draw. They didn't draw the whole thing. So they only drew. All right. So I'm gonna go ahead and graph my equation. I'm not sure what's gonna be easiest, so let's review this and let's review. How do you graph something like this on a regular rectangular system? What's that? Midline? So it starts the midline. Alright. Amplitude is 4, so going up 4, so up to 6, and down 4, so down to -2. I don't have a period change, so it's a regular old period, the quadrants. Because there's no coefficient there, right? So I start up here, it's cosine, so I start up here, cross there, bottom out here, cross there, and up here. Hope nobody's forgotten this. This is big time, we gotta remember that stuff. That look okay? Now these things with that vertical shift in them, they kind of complicate it a little bit. This point right here is very, very important. So is this one. Those are the points where I'm actually crossing the axis, which means those are the places where I equal 0. I need to figure out what those are, because those are my pole points. So I need to figure out what those are. So where does this equal 0? I want this equation, I want to know where it equals 0. Well, doesn't that say that the cosine is -1/2? Where does that happen? Cosine is negative, well, it's a pi over 3 angle, but it's not pi over 3. It's 2 pi over 3. Did you say 2 pi over 3? Oh, I didn't hear that, sorry. Remember, I'm 66, give me a break. 2 pi over 3 and 4 pi over 3. So here's 2 pi over 3 and 4 pi over 3. Okay, so these are all kind of the important points. So let's start plotting them. This would be the point where R is 6, theta is 0. This is theta and R. So at pi over 2, R is 2. At 2 pi over 3, R is 0. So can you kind of visualize what's happened here based on what you graphed before? What happens at pi? At pi, I'm at negative 2. But I can't plot that point, I have to plot it over here at 0. Negative radius. Whoa, that's good news. Isn't this part of what I'm looking for? What do I need it to do now? I need it to get back to the pole. And where does it get back to the pole? Back to 0. 4 pi over 3. So where did it first hit 0? 2 pi over 3. And then it circles back around and gets back to 0 at 4 pi over 3. So my interval is that. 2 pi over 3 to 4 pi over 3. Yes? So answer D. All right, let's put that away and get our notes down. No, that's his part. If you take the cosine, it's going to give you a negative number. Times it by 4, it's a bigger number. And it ends up being quadratic in 4. Because these are quadrilaterals.
Before practice, how do you know how far to go, like, on, like, the left side of the
Over here, I don't.
Okay.
I mean, I wouldn't know that unless I plotted some more points
Okay.
in there. But that really isn't of any concern to
Okay.
me, because this is the only part of the graph I care about. I just wasn't sure when I got there.
Yeah.
And I got there right here. And I left it there right here.
Okay.
So this is a little interior loop.
Yeah.
This stuff is the rest of the picture,
Okay.
which I didn't really out in this problem. Right? Might be time to do some kind of organization around it.
It's a good board compared to mine.
Okay, let's take a look at our notes here. All right, rates of change. So we're going to do a little average rate of change stuff in here. But first, I want you to look at example 1. Okay, I want you to look at example 1. Are we all looking at example 1? 1 plus 2 sine x has been graphed, labeled, everything's perfect. What interval or intervals is this curve, 1 plus 2 sine x, positive and increasing? On what intervals is it positive and increasing? 0 to pi over 2, definitely. And 11 pi over 6 to 2 pi. What does positive mean? Positive means it's above the x-axis, the horizontal, the polar axis. So I want to be above that, but also increasing, so going up. And those are the two pieces. Would everyone agree with that? Okay. Where are we positive and decreasing?
Pi over 2 is 7 pi over 6.
Pi over 2 to 7 pi over 6. Any other places? Nope, that's it. How about negative and increasing? Negative and increasing. 3 pi over 2 to 11 pi over 6. Perfect. And where are we negative and decreasing? 7 pi over 6 to 3 pi over 2. So that's right out of unit 1. Is everybody okay with that? Okay. Now, it's the next little chart, which he has completely filled in for you, but this is the interesting one now that we have to look at. So he says from A to B, that is the interval from 0 to pi over 2, okay? And it's positive and increasing, right? And then the distance between your point and the origin is increasing on that part of the graph. Would you agree with that? In other words, R is increasing. In other words, we are getting farther away from 0. Would you agree with that? Yeah. Now let's look at the next one. From pi over 2 to 7 pi over 6, you already told me the curve is positive and decreasing. What is happening to R? On that part of the curve, what is happening to your points? Aren't they getting closer to 0? Aren't we coming down? So we're getting closer to 0, which means R is decreasing. And when that stops, it's so silent. Okay, how about from 7 pi over 6 to 3 pi over 2? Look at your picture. 7 pi over 6 to 3 pi over 2, you already told me it's negative and decreasing. Right? What's happening to R? Is R on that little part of the graph, is R increasing or decreasing? R is actually increasing. Isn't R getting bigger? I'm talking size-wise. Aren't I getting farther away from 0? Okay, it's like right here. It's like this part of the graph, right here. Isn't R increasing? Because I am getting farther away from the origin, farther away from the pole, farther away from the x-axis.
But it says that R is equal to y. And like if it's going down, wouldn't it be decreasing?
Okay, we're talking about the radius of the thing.
Oh, it says like
Yeah, no, it is. I'm thinking about the R's as y values. But I want to know what is happening between y and the origin. What is happening to that distance? What is happening to this distance? These are all y values. This is like the origin. This is 0.
Oh,
What's
yeah,
happening
yeah,
to
it's
this?
getting further. Like
Yeah,
on the
getting
pole.
farther away.
Okay.
Getting farther away. That's what the distance from the origin. All right, next, D to C. 3 pi over 2 to 11 pi over 6. Now we're talking about a piece that looks like this. What is happening to the distance from the pole? Right here, what's happening? It is decreasing. Aren't I getting closer? So the distance is decreasing. And then what happens on that last little section? The distance is increasing. We're getting farther away. All right, now we'll see what you can do on your own here. Now, the tricky part here is, and this just happened to me last period, you have to make sure you're reading the whole question. Okay, so the picture is drawn. See the graph of f of x down there? Wait a minute, is that, no, that isn't the right graph. I don't have the graph. Nope, so I don't have the graph, so I'm gonna graph it myself, because I don't have it. So. Oh shoot, was I writing over there? Oh darn it, oh well. Before I turn off the iPad, take a picture of it. All right, let's sketch 2 minus 4 cosine theta. I don't see that drawn.
It tells us at the top, that's like helpful to sketch it.
Yeah, it always is, I draw everything, but he normally includes a graph, but I don't see it here, so we're gonna go ahead and do it. So, what's this gonna look like? What's its midline?
2.
2. Amplitude is 4, so this is kind of like the one we already did. The difference is now it's going to be upside down. Because of the negative. I like to think of it as negative 4 cosine plus 2. So it's going to start down here, cross here, peak here, cross here, and down here. All right. So here it is. Now, just for extra practice, I don't know if we're going to need this or not, but these points are important. They aren't labeled, but they're important. These are the places where that equation equals 0. So can we figure out what those labels are? Well, if we solve that equation, doesn't that say cosine is 1/2? Did I get my signs mixed up? But since that's negative, wouldn't that be cosine equals 1/2? Where does that happen? Where's the cosine 1/2?
Over 3.
Pi over 3 and 5 pi over 3? Now, I don't know if I need those or not, but just for practice, now we got it. Okay. All right, so let's look at question, or part A. The distance, we're talking about the distance between the point and the origin. This is the origin. This whole line here, this is 0. The distance is increasing from pi to 5 pi over 3. Wait a second. From here to here, is the distance to the pole increasing? No, throw that out. Okay, that's not. From 5 pi over 3 to 2 pi. So now I'm looking at this little piece of the graph. This is question B. The distance from the pole is increasing. Is that true? Yes, but read the whole question. Because f of theta is negative and increasing on the interval. Is f of theta negative? Yes. Is it increasing? No. So it's not B. It's not B. There's 3 things going on in that question, and 2 of them are true, but the other one isn't. So, not B. All right, is it C? Pi to 5 pi over 3, so I'm looking at this right here. Is the distance decreasing? Yes. Is f of theta positive? Yes. Is f of theta decreasing on the interval? Yes, C is the correct answer. All 3 things are true. The distance to the origin is decreasing, the curve is positive, and the curve itself is decreasing. Now, someone asked last period, well, do you really need to say both of those are decreasing? Yes, because look at this little part. Is the curve decreasing? Yes, but what is the distance doing? Increasing, yeah, they are separate things. All right, try example 3 with your partner. The graph is drawn this time. And you want to know on which interval is the distance from the origin decreasing. On which interval is the distance to the origin decreasing? Can you figure that out? Who Who am I missing here? Avery, Mark and Ella, yeah. And Gus's target is pass. That's it, okay. Have you found an answer yet, guys? What do you think? C, you're exactly right. Fred, explain C, because I think some of them don't have it. How did you know it was C?
Because, it's getting closer to the y-axis because it's negative and increasing.
When we want the distance to decrease, don't we want to get closer to the y, or closer to the x-axis? We want to get closer to the x-axis. So he said the answer is C, because from 3 pi over 4 to pi, what's happening? We're getting closer to the x-axis, the polar axis. Perfect. All right, let's take a look at example 4. Can you sketch, like this right here, can you sketch the equation in number 4? I think it will help you a lot if you can. And you've been watching me sketch them all, period, but you need to remember how to do it also. Does your picture look like this? All right, let's look at the interval from pi over 3. Wouldn't pi over 3 be in here somewhere? So from pi over 3 to 2 pi over 3, the interval from somewhere in here to somewhere over here, that interval, so this part of the graph right here. Is there a relative minimum in that interval? No, absolutely not. Not true. The whole thing is increasing. That whole piece of the curve is increasing. To have a minimum, you have to go from decreasing to increasing, right? And this whole thing is increasing. All right, so it's not that one. How about from 2 pi over 3 to pi? Now, from 2 pi over 3 to pi, we do have a change, right? We do have a change, but I want to have a minimum on that interval. From 2 pi over 3 to pi, aren't we increasing and then decreasing? So that is not a minimum. How about C? Pi over 3 to 2 pi over 3. No, nothing is happening there. It's increasing. It's not C. Better be D. From 2 pi over 3 to pi, I have a maximum. Yep, we have a maximum because we change from being increasing to being decreasing. That would be visible on the polar curve too, but I think it's harder to see. I think it's easier to see a maximum when you write it with X's and Y's. All right, so the answer is D. Okay, example 5, average rate of change. What do you remember about that? enthusiastic when we come in and then we get like this. What do we need to do? We need the average rate of change. I'll use the correct variables, but you can certainly remember it in terms of f of x when we did it before. Do you remember your average rate of change form? I'll call it a formula. How do we calculate the average rate of change? Our interval is from pi over 2 to pi. So it will be f of pi minus f of pi over 2 divided by pi minus pi over 2. Remember that? So then to evaluate f of pi, we put pi in right there. So what do we get? When we put pi in, what's the cosine of pi? -1. So this is going to be 3 plus 3, 6. And then put pi over 2 in, we need f of pi over 2. What's the cosine of pi over 2? 0, so that's just going to be 3. And that's going to be over pi over 2 when I subtract those. So I have 3 over pi over 2, which is 6 over pi. Is that okay? And I don't really have any units going on here. I know theta is in radians. So this would be like inches per radian or feet per radian or something like that. Would be my unit. All right, let's look at example 6. On which of the following intervals is the average rate of change equal to 0? So think about doing this problem right here. If you wanted this to come out to equal 0, what would have had to have been the case? The only way for this to come out to be 0 is for that to be 0. And the only way that can be 0 is if these two are the same, right? So in other words, f of pi over 4 and f of 3 pi over 4 would have to be the same value. I'm looking at answer A, just for fun. Now, if you can't tell from the polar graph, you can graph it rectangularly and it will be easy to see where they match. It will be easy. So we've got y equals 3 sine 2 theta. So since a lot of my intervals are bigger than that, I'm going to go ahead and go all the way to 2 pi. And it's a regular sine curve with an amplitude of 3. So here we go. There's 2 periods of it to get me all the way to 2 pi. Where do I have matching y values? Pi over 4 and 5 pi over 4? Is that an option? Nope. 3 pi over 4 and 7 pi over 4? Yep, there it is. Answer C. If your average rate of change is going to be 0, your y's have to match. These have to be the same number. And that happens here and here. It happens other places too. But for our answers, that would be the choice. Well, the next one, they didn't give me an equation for. Tell me about the average rate of change from point A to point B. Wouldn't it be zero? It absolutely would be zero. Very good, Fred, thank you for paying attention. How about from B to C? Now, I don't know what it is, but look at the directions. I want this to be the least. I want the average rate of change to be the smallest it can possibly be. So what is happening from B to C? Isn't the rate of change gonna be positive? Something positive? What about from C to D? Zero. And what about from D to A? Negative. So which interval has the smallest average rate of change? D to A. D to A, because it's a negative number. All right, one more problem, and we'll be done. So 315 is going to be due on Tuesday. One more problem. Here we go. We have a table of values. Oh, come on. Oh, it's easy though. It's easy. Yeah, very, very easy.
Easy for us or easy for you?
Easy for all of us. Okay, so let's look at our chart. This is a chart just like X's and Y's, just like we had before. Now we're doing things with angles, not a big deal. We're gonna find the average rate of change. Okay, step one, find the average rate of change, which by the way is equivalent, same thing as slope, right? Slope. So we're gonna find the average rate of change or the slope. So we're gonna take f of 7 pi over 6 minus f of pi over 6 and divide that by 7 pi over 6 minus pi over 6. Don't be confused just because it's in chart form. You take this y minus this y, so that's f of 7 pi over 6 minus f of pi over 6 over your x minus your x. So that's negative 1 minus 2 over pi. So your average rate of change is negative 3 over pi. Y minus y over x minus x. Yes, Alex?
Can you still do like? If
Is
you,
my math wrong, Alex? You're looking at it funny.
can you still do like 2 minus negative 1?
No.
Over
Nope, we're on the
x.
end, it has to be second minus first, gotta be B, what they call B minus A. On the end of it from here to here, it's gotta be that minus that. Okay? Now, will the answer come out the same? Yes, but for formal purposes, this is gonna be a rated question, this is gonna be on the exam, 100%. Some average rate of change thing, you gotta have it set up the right order. Okay, all right, so now I have that. All right, so now my job is to sort of like write the equation of the line between those 2 points. And then you're going to use that equation to approximate another point on the graph. Okay, so how do we do that? How do we write the equation of a line? Well, we pick one of our 2 points, right? Which one do you want to pick? The first one or the second one?
Second
Which one?
one. Second one.
Second one? All right, so you're gonna write y plus 1, and I put y, I should be putting f of theta plus 1, that's y plus 1, and what's that gonna equal? What's that gonna equal? Negative 3 over pi times theta minus 7 pi over 6. This is y, that's x. You haven't forgotten how to write the equation of the line, have you? That's the point slope form of the line. So f of theta is gonna equal negative 3 over pi, theta minus 7 pi over 6, minus 1. Your job is to find f of 5 pi over 6. So what are we gonna do? So negative 3 over pi times 5 pi over 6 minus 7 pi over 6. I didn't distribute here, I could have. If it's easier for you, I didn't, but you could have. I'm plugging 7 pi over 6, or excuse me, 5 pi over 6 in for my theta. You could have distributed. So what have I got in there? So 2 pi over 6 would be pi over 3. What happens here? Isn't that just 1? So the average rate of change is 0. Now, that isn't gonna happen every time, okay? That happened because they picked 5 pi over 6. If he'd have done, some other number, then you wouldn't have gotten 0, but this is the math you would have done to get it.
So the average rate of change is 0?
No, the average rate of change was whatever we got, negative 3 over pi. 0 is the y coordinate when you put in 5 pi over 6. So if you expanded your chart, if x or theta is 5 pi over 6, the y value is 0. This is a y value that you were finding. It's actually an R value, but let's say the y value. Okay, so you can make the chart as big as you want it. Pick a different, pi over 3. Plug that into your equation and you would get a different value. Okay, all right, I'm gonna stop right there. Next time we are together, we will start some review work.
And this when we were doing like the stuff on the board.
All right, because I accidentally wrote on the wrong side of the board, this was the couple of the problems that we did at the beginning. There's a picture of it, so if you go back to the explanation when I'm blabbing, that's it.